All right, welcome to the Explainer. Today, we're going to crack a secret code, one that pretty much runs the universe. I'm talking about everything from the shape of galaxies all the way down to the GPS in your pocket. So let's just dive right in. What do rainbows, GPS, and these massive swirling galaxies all have in common? I know it sounds like a riddle, right? But the answer? It's just a single, really mysterious number. And that code, that secret number, is pi. You know it, right? But it's one of those things that seems so simple at first glance. But it turns out it's hiding literally everywhere, right in plain sight. Okay, so what is this number really? Let's kind of get back to basics and uncircle this famous number. We're going to break down its super simple, super elegant definition. Okay, here's the core idea. Pi is just the ratio of a circle's circumference, that's the distance all the way around it, to its diameter, which is the distance straight across. And here's the crazy part. It doesn't matter how big or small that circle is. A dinner plate, a planet, if you divide the circumference by the diameter, you always get the exact same number. And that number starts with a very familiar 3.14159, and so on. But this is where it gets really weird. See how those digits just trail off? They literally go on forever. And because they go on forever with no repeating pattern, that makes pi what we call an irrational number. Think about that. It means you can never, ever write down its exact value. It just keeps going. You know, this number is such a big deal, it even has its own holiday. Pi Day is celebrated every March 14th, 314. It was started way back in 1988 by a physicist named Larry Shaw. And get this, as a cool little bonus, it's also Albert Einstein's birthday. How perfect is that? Okay, but here's the thing. Pi doesn't just stay inside a circle. This is where the story gets really, really interesting. This is the number that's hiding everywhere, from nature right down to your phone. I mean, think about it. It shows up in the arc of a plane's flight path, in the actual spiral of our DNA, the ripples in a pond, and it's not just nature. It's in the signal processing for your Wi-Fi, it helps track population dynamics, and yeah, it's crucial for calculating your location with GPS. It's everywhere. But hang on. How can a number that comes from a simple circle show up in something like waves? I mean, a sound wave isn't a circle, right? So what's the connection? Well, the answer is just so elegant. A Reddit user, BigOak8056, put it perfectly. It's actually the path traced by a point on a circle as it rolls along a path. Just picture that for a second, a wheel rolling along the ground. The path that a single point on that wheel makes, it's a perfect wave. So it turns out circles are secretly hiding inside the math for waves all over the place. So this infinite, never-ending nature of pi has made it an absolute obsession for people. For centuries, we've been in this epic race to infinity, a human quest to calculate more and more of its digits. And this race has been going on for a long time. I mean, way back around 150 CE, Claudius Ptolemy got it to 3.1416. Then, around 480 CE, Zhu Chengji in China nailed it to 7 decimal places. Fast forward to the 1430s, and Al-Kashi gets it to 16 places. But then, look at the jump. 2009, we hit 2.7 trillion digits. 2022, 100 trillion. And by 2025, a projected 314 trillion. The pace is just insane. So how is this even possible? Well, the big tool behind these modern records is something called the Chudnovsky algorithm, which was published back in 1988. It's an incredibly fast, incredibly powerful way to do this calculation. And that very algorithm is what has allowed us to push the limit to just an astonishing 314 trillion digits. It's a number so big you can't even really comprehend it. Okay, but this brings up a really big question, right? Why? Why chase an endless number? I mean, NASA only needs about 15 digits of pi for its interstellar calculations. So what's the point of all those trillions of other digits? Well, the reasons are actually pretty fascinating. First, it's the ultimate stress test for new supercomputers. If your machine can calculate pi to a new record, you know your hardware is solid. Second, it's about exploring math itself. Pushing these limits helps us find new patterns and develop new techniques. And honestly, the third reason might be the most human one of all. It's just pure curiosity. It's a challenge, like climbing the highest mountain. We do it simply because it's there. But what if I told you the weirdest part of this whole story isn't how many digits there are? What if the weirdest part is that you don't even need a circle to find pi in the first place? Okay, you have to hear this. There's this 18th century experiment called Buffon's needle problem, and it basically proves you can find pi by just dropping needles or toothpicks onto a sheet of lined paper. Seriously, you just drop them over and over, and you use probability. The chance of a needle landing across one of the lines is directly connected to pi. It's math hiding in what looks like pure random chance.
So, what does this all mean? It means pi isn't just a number about circles. It's something much deeper. It seems to be a fundamental constant of the universe itself, woven right into the very fabric of reality.
Which leaves us with one final big question to chew on. If pi is hiding everywhere, in plain sight, what other mathematical secrets, what other universal codes is the universe just waiting for us to discover?